Okay, so we'll get started even though very few people have shown up today. We'll get started. We'll at least start with homework review and then we can start the next topic as people join. Actually, before I start, anyone who wants to, actually, I don't even remember the questions right now. So let's open the question. Okay, so first question, anyone who wants to volunteer about who has some thoughts on how to do first question? Anybody? How to find the LCM of several numbers? What was the question? How to find LCM of a list of numbers? Any thoughts on how you would do that?
So I defined a list containing the numbers 2, 3, 4, 5, and 6. After that, I used a, the range of the LCM. We found that out by checking which number is the biggest in the entire list, and we put that number in the first in a for loop, and then we multiplied all the numbers to discover what was the biggest possible LCM. Once that was done, we divided and checked for if the remainder is 0. If all remainders equal to 0, then that was the LCM and it will print it.
Okay. One method. Anyone else? Any thoughts?
I first created a prime variable and started it off as being 2, and then I checked whether it was prime by like a for loop, and then I divided the prime number by each of the numbers, and if it was divisible, I would change the number to be the number divided by the prime number, so it would change the value, and then I would append the prime number to a factor list, and then once I have all of the factors, then I would multiply to get the LCM.
So you did something like ladder method for using LCM for finding out LCM when you do on paper, roughly,
Yeah.
right? Okay.
Yeah.
Anyone else? Any other method? Someone else who tried some other method? Shruti Satyanarayan, you said you think you know. So what was your method? Oh, sorry, that was you. I'm sorry. Anyone else? Okay, so let's try something. What is the LCM of 2 and 3? What is the LCM of 2 and 6? Okay, what is the LCM of 6 and 4?
12.
12. What is the LCM of 12 and 5? 60. What is the LCM of 60 and 6?
60.
Okay, so what did I do here? I had a slightly different method than you guys explained, right? What did I do here? Of course, I'm not saying this is the best method.
Each individual pair.
Right, exactly. Yeah, if you find LCM of each individual pair, then you find LCM of everything. Ladder method is definitely very useful, when you are doing by hand. Because by hand doing pairwise LCMs is a lot of work, right? You have to, if let's say you have 20 numbers, you had to calculate pairwise LCMs 19 times. That's a lot of work. But ladder method is also not such advantageous if the numbers are relatively co-prime. What does relatively co-prime mean?
Is it all prime?
Not really. 2 and 7, not 2 and 7. Let's say 2 and 9. Is there any common factor between 2 and 9 other than 1?
No.
Right. So 2 and 9 are co-prime or relatively prime. So in those cases, if the numbers are relatively prime or some numbers are relatively prime, ladder method takes a lot longer. Both yes, exactly. Is co-prime just like you multiply both the numbers? Yeah, absolutely. Yeah. Yeah. If two numbers are co-prime or two numbers are relatively prime with each other, if they have only a common factor of 1. Exactly. LCM 2 times 9 is 18. Absolutely. Right. So it's not definitely not wrong, but when you're trying to do with computer, it doesn't have a problem calculating 19 LCMs, right? How do you calculate LCM of two numbers?
Ladder method?
Two numbers, do you use ladder method? Anybody else? Product by GCF, perfect. Okay, divide the smallest number out of the two. Dividing, what does that get? So basically, it's I don't know if you guys have seen this in the past, but let's see. So how many of you know this trick? Basically, LCM equal to LCM of two numbers is equal to product of numbers divided by GCD of numbers. Have you guys seen this trick ever, or have you used this? Comparing the numbers if both have factors. Yeah, definitely. No, there are definitely other methods, like when you do in class, for example, when you're trying to do for 3 and 7, you multiply them, you get 21. If you're doing for 3 and let's say 14, you probably again multiply and get 42. 2 and 6 is 6. So in some of these cases you're multiplying, in some of these cases you're dividing. But easiest way, or at least one of the easiest way in which you can do, is basically always multiply the two numbers, then divide by the common factor, greatest common factor of the two numbers. Why is that easier? Or at least why is that faster, if not easier? Why is that faster? I'm not claiming it is easier. Sometimes it's super slow. I mean, super difficult, but why is it faster for a computer to? No, not because I said so. But is the LCM of two numbers ever smaller than the numbers? No. Is the GCD of two numbers ever bigger than the numbers? Right. So when you are looking at the GCDs, you'll never exceed even the smallest of the smaller numbers, right? When you have a pair of numbers, the GCD at most is the smallest of the pair of numbers. So for any two numbers that you get, the GCD is always smaller than the smallest number. So you just have to check factors that are smaller than the smaller of the two numbers. Hence less number of things to check. But again, depending on what you are doing, sometimes it may take longer to calculate GCD than to calculate LCM. But Usually it should be a smaller number, and hence probably lesser number of checks are sufficient to find out. And of course, if you can prime factorize the numbers relatively quickly, you would get even faster, because once you prime factorize, calculating GCD is even more faster. Wait, what happens if you miss a class? If you miss 2 classes, then you're out. If you miss 1 class, then you're okay. So this method is relatively easy, and as I said, if you guys got this idea, or if you tried the ladder method and got it, that's great. Oh, okay. Yeah, then you can explain what we went through in this class. Yeah, that's right. 2 classes back to back, if you miss, you'll not be able to follow sometimes, depending on where we are missing. For some of you who already know some of this stuff, maybe if you miss, that's okay. But for those of you who may not know any of the material, then missing 2 classes back to back is difficult. Okay, so the next thing. So this question, anyone else has any questions? Anyone else has any other questions about how to calculate LCM or any other methods that you guys tried? So we so far looked at 3 methods. Jonathan's method was multiply all the numbers and then divide by common factors till you ended up with LCM. Right, Jonathan? That was roughly your method, right?
Yeah.
Shruti's method was ladder method. I said pairwise LCM by using this. Anyone else tried something else? Okay, so if you guys haven't tried something else, then we'll go to the next question. So what was the next question? Reciprocal of a number, right? So how do you find reciprocal of a number? Yeah, good try. But you had to return an array, a list with the the digits in the reciprocal which were non-repeating, right? Or the non-repeating portion of or the one-time repetition of the repeating digits. So how do you do that? If you just do 1 by number, what do you get? If I do 1 by 7, what do I get? I get this. So how do I only make it return 0.142857? Any thoughts, anyone? Okay. No, that doesn't look right. Floor, what does floor do? So if I do floor of this, what does it do? Is that even? So I did it 0, right? So floor, seal, not so useful. So first of all, if you guys were to do this by hand, sets could work, but that changes the order, so I didn't use that. Yeah, that's a good idea. Sets could work, but again, you're thinking in terms of, does a set detect a pattern, or does a set detect duplication of an individual number? Duplication of an individual element, right? Right. So It detects duplication of individual. But actually, just that you, as you guys mentioned, I can actually, we can actually come up with a set-based solution also. So let's see two solutions. One which is something that all of you have done already. So if you had to do 1 by 7 on paper, how would you do that? If you had to do with a pen and paper, how would you do that?
No, you just 1 divided by 7.
Right. So what's the method? The long division, right?
Yeah.
Okay. So long division, you can also make a computer do long division, right? So how do you make a computer do long division? So how do you do long division? Let's try to write down that one. So let's see, maybe if I go to paint, it's more easier for me to do long division. So let's take 7 and 1. So what do you do first? Is 1 less than 7? Make result as a string. Okay, so first you put a 0 because or a decimal point, whatever. That means you have basically effectively multiplied by 10, right? See what multiplied by 7 makes 1, but there is none. So you add a 0 inside and the decimal point on top, absolutely. Then what do you do now? 10 is divisible by 7. So what do you do now? So you put a 1 on top, right? So then you put a 7 here. Now subtract this number. So you got a 3. What next? Bring down another 0. Okay. Multiply by. Okay, perfect. So you don't have to do anything to do that, right? So if you had to add 1 0, you don't have to do anything else. So put a 4, then 28. Now 2. Put another 0, right? A 2, 14. Now a 6, another 0. So what's the next digit? After 1, 4, 2? 8, okay. So that gives me 56. 4, another 0. Now 5, okay, 35. So 5, another 0. And then 7, okay. So 49, and now we are left with a 1, right? So we started with a 1, we ended with a 1. Of course, you don't have to end with the same number you started. So if you end up getting one of the previous reminders that you already got, then there is no doubt that you will repeat, right? So to give only the non-repeating part of the quotient, all you have to do was find where the remainder repeats. If the remainder repeats at some point, whatever are the digits in the quotient till that point are part of the non-repeating portion. Everything else after that will be part of the repeating portion. So that's how you did long division, and you figured out, okay, this would really give you this. So you can do the same thing in programming as well, right? You start with a number called numerator, right? It's equal to 1, and you start with the denominator equal to 7. If numerator is less than denominator, multiply it with 10. What if you had to multiply with more than 10? Instead of 1 and 7, what if it was 1 and 77? What would you do if I had to find the reciprocal of 77 instead of 7? So do you put only 1 0 on the top now? by 10 again in the loop, right? So, but you also have to put a 0 in the quotient, right? So it's now 0.0, right? Add one more 0 at the top. Absolutely. So anytime you are multiplying with more than 10, you have to make sure you add a 0 to your quotient. Remainder is not changing, but quotient is changing. Or you can add the same number as the remainder and make a quotient as 0. So that's the story. So what do? You create two lists, remainders and quotients. Because repetition is based on remainder, answer is the answer that we need is the quotient, right? So initially reminders are empty list. Quotient is also an empty list. Then you loop. Till what? Till what do you loop? So till when do you have to keep dividing? Till you see that it is repeating. But what about if I did reciprocal of 2? Oh, that is not update Windows. Who was saying like that's some software update. Yeah. So 2, 1. This doesn't repeat, right? What is this? One decimal digit, 5, 10. So until a digit in the quotient repeats, that's the right answer for when a digit repeats. What if it doesn't repeat? Until 0 is remainder. So you have two termination conditions, right? Your loop has to keep on going till one of these two conditions are met. In these cases, which kind of loop is better? Is a for loop better or while loop better? You don't know how long you have to continue, but you know once while loop is better. Very nice. Okay. So a while loop is better. So you simply say while true, right? You can even say while true. Let's try. I'll not give the entire solution. We'll just go over high level. So numerator equal to 1, denominator equal to whatever. So in this case, we'll start with 7. Remainder is a list. Quotient is a list. And I'll also say is repeating as a flag, and I'll say false. Right. So these are my five starting variables. So while true, what do I do? If numerator is less than denominator, numerator equal to numerator times 10. Right, that's my starting point. Didn't you have to, yeah, you have to write a function, but this is the logic. This is not the function. This is the logic inside that function. I'm not going to write the entire thing anyways. So next, what do? How do you find out what's the quotient when you divide this? So quotient equal to what? So 10 divided by 7, what's the quotient and what's the remainder? Okay, so numerator divided by, but in Python, what does numerator divided by denominator give you? Does that give you an integer or does that give you a float? It gives you a float, but are quotients floats? No, right? We want quotients to be individual numbers. So how do you do that? Floor, okay. Or you can convert cast as int. That's also going to work. We can do floor also. So import math and math.floor. How about the remainder? How do you get the remainder? Now, how do you get the, so 10 divided by 7. Quotient is 1. What's the remainder? Oh, okay. Yeah, percentage, right? Yeah, percentage or this will give you, or modulo or division or whatever, this will give you the remainder. So now what do you check? If quotient in quotients, then break, right? Sorry, if remainder in remainders, sorry, not quotient in quotient, if remainder in remainders, or if remainder equal to 0, break. Else what? Else if, okay, elif, yes, absolutely. Because I'm using breaks, it actually doesn't matter if I do else, if, or if else if, because once you hit this condition, you're going to break anyways. It will not go to this else if, it will go out of this loop. So if break is the same as if, or if else if. So it wouldn't really change, but yeah, else if is better. Should we print 001 or 01? You should print 001, right? Right, so that's it. So here else you add the reminders, reminders dot append of reminder and quotients dot append of quotient. In this case, is repeating equal to 2, right? By default, we are assuming that it does not repeat. So is repeating equal to true here, else it's not. Else is not breaking, right? So this is not a break condition. So I don't have to set is repeating at this point. This is not the end of it. Only at the end, I will know whether it is repeating or not. I won't know as I calculate each digit. I won't know whether the reciprocal has a repeating portion or not. Hence, I can't change it here. Right. I mean, if you want, you can say is repeating equal to false. It's not really going to cause any harm, but strictly speaking, we don't know at that point if it is really repeating or not. So that's the general idea for long division. What does if remainder in remainders mean? Isn't the remainders empty there? Yeah, if it's empty, it will initially say false, right? It says false, and it would either come here or here. Right, but then I add the reminders. Isn't it else? Not else if. Yeah, okay, else. So that's roughly the general idea. Any questions? Can we test it? Yeah, there is one small problem here. We have to change the numerator also at the end of this loop, because numerator should have reduced also, right? Or numerator equal to remainder. Right. So we should change this. Can we test this? Yeah, let's see if we can test this. So 1 divided by 7 is not a function. So let's see if we print it, what does it return? So 142857. Yeah, it seems to work. Do we need the reminder? No, I'm just showing you both of them. No, you don't need the reminder. You just need the quotient. And of course, I have to add a 0 to this quotients array once it finishes. Like once it's finishing, we have to append a 0 at the beginning. Right? So this is one idea. Anybody else tried anything else? Oh, yeah, sure. This is what I did. Oh, okay. So somebody, okay. Reciprocal is equal to string of 1 over number. In list equal to 1, out list for element in reciprocal. If element not equal to dot, in list dot append of element. For x in list, what is x in list? If x not in outlist dot append, return outlist. Okay, let's see. Okay, that's nice. It works for 7. Works for 8. So yeah, see, this is the problem with this method. So let me see what's the reciprocal of 1 divided by 983. So the reciprocal of 1 divided by 983 is a very, very big number. The problem you're running into here is this: when you do string of, so let's do 1 divided by 983. It's stopping at some point, right? It did not repeat really at this point. And in your integer representation, you didn't even get that really, right? So for 7, you are lucky basically because 7 has all the digits in the non-repeating part of 7 are unique. But it's not the case for all reciprocals. For example, in this 1 divided by 983, okay, it just removes duplicates. Yeah, probably not. If you're just removing duplicates, probably not. Yeah. Now we can check your solutions later, but idea is not to remove duplicates, right? If the idea was to remove duplicates, in this case, in the reciprocal of 1 divided 983, is there really only 1 0, 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, 1 7, 1 9? Or is this the reciprocal without repetition? Right? When you say show the non-repeating terms at least once, it means whatever is the repeating period and then one time of that. You should show that is that much. So let's see what's the length of this. I think the length of this is over a few hundred. So 982, basically 983 is a special kind of number. These are called, I think, for maths little theorem. Yeah, a power p minus 1 equal to 1 or a power p equal to a mod p. So what that really means is, yeah, you could probably read up a little bit about this. It will take a lot of time to explain. I think that's the reason why 983 gets this. Good joke, Prince. So for those of you who got the joke from Prince, just so he says, my code is so long it doesn't even fit in the chat. Any one of you know what's the relevance of that joke to this page? So this French mathematician called Pierre de Fermat, yeah, he invented a lot, or he came up with a lot of theorems. Not infinite, yeah. So this French mathematician came up with a lot of theorems. One of his most popular theorems is something all of you guys know also. What is 3 square plus 4 square equal to? 25, which is the square of another number, right? What square is that? 25 is the square of which number? Okay, 5 square, sorry. So this is Pythagoras theorem, right? So what Fermat said is, or his one of his most popular, yeah, so a square plus b square equal to c square, right? That's Pythagoras theorem. So what Fermat said is a power n plus b power n is not equal, yeah, you'll get a lot of Pythagorean triplets, is not equal to c power n. I'll give you some, yeah. If n is greater than 2 and a, b, c are natural numbers. So he said this. And then he also wrote in that book, he was, I think he was reading this book by Newton called Principles of Mathematics or Principia de Mathematica or something. So in that book, in the margin of that book, he wrote, I have a truly marvelous theorem, proof for this theorem, but the margin is too small to contain this. He wrote this in 1620s, and for almost 300 years, nobody could solve this. Till in 1995, a British mathematician finally solved it. His name is Andrew Wiles. He's considered to be the greatest mathematician alive right now. So it took almost 370 years for people to solve something that guy thought he could write in. He couldn't write in because the margin was too small. So when Prince said his code is too big for it to fit in the chat, that's kind of the same joke. So he was right. He made this as a note. All of his theorems were like notes in his textbook. He was reading a textbook called Principles of Mathematics, written by Isaac Newton, I think, or somebody else. I don't remember which textbook he was reading, but that was the story. Well, obviously in a textbook, you will have margin like this, right? Yeah. So if you, and no, not this one. It's probably a small enough margin. So that's the story. So this is the question. So now obviously, why did I choose 983 in the previous answer? So the next question in the homework was find out for all positive integers whose reciprocals have repeating digits, find the number whose reciprocal has the most repeating digits. I almost gave away the answer. 983 is the answer because it has 982. Is 983? Yeah, 983 is the answer for 3. Absolutely. Yeah. That's why I was testing with that number. So the reciprocal for 983 has 982 digits, and after that it repeats. So if you are not believing that, we can try printing. Or we can print reminders. So it starts with 1, right? So see here, it ends with a 1. Do you see that? And the claim is nowhere else there is a 1, absolutely. Oh yeah, yeah. This you'll get in solutions. It's already there in the solutions. So it ends with a 1, a small 1 here. It's probably hard for you guys to see on the screen, but yeah. So it ends with 295 and a 1. I got 9967 for number 3. Oh, was it for up to 10,000 or 1,000? Oh, 10,000. Sorry. Yeah, maybe when I did it, I probably did it for only 1,000. Sorry. So yeah, maybe it's 9967. Let me see what's for 9967. 9966. Yeah, quite possible. Yeah. So 9966. 9967 seems to be the right answer. And I got 1 divided by 5,007. I got 5,700 for 1 divided by 5,701. Yeah, quite possible. There are a lot of numbers whose LCM, whose reciprocals have 1 digit less than the number itself. Any number that satisfies this property, which we were seeing earlier, if the number power 10 is divided by 10 gives the number as the remainder. Yeah, what are we learning today? Soon we'll learn about more functions, but Now, how about for non-repeating numbers? Do you have to do all of this for non-repeating numbers? No, you don't have to do all of this. So what's the answer for non-repeating numbers? (9968). Interesting. What's the reciprocal of 9968? It's 8192, right? Yeah, 8192, absolutely. So why 8192? What are the factors of 1 or what are the factors of 10,000? Yeah, 1 divided by 8192, that is the reciprocal. Yes, absolutely. So what are the factors of, why is 1 divided by 8192 the correct answer? You don't even have to use a calculator. Actually, you can do this in your head. Why is it the answer? Okay, so hint. What are the factors of 10,000 or what is the prime factorization of 10,000? Anybody? What's the prime factorization of 2 power 4 times 5 power 4? Very nice. So 2 power 4 times 5 power 4. So for any number which is between 1 and 10,000, the reciprocal of a number of that number does not have repeating digits if that number is a factor of only 2s and 5s is the claim. So for example, 1 divided by 2 does not have any repetition. 1 divided by 4 has no repetition. 1 divided by 5 has no repetition. Because you are effectively dividing 10 by 2 or 100 by 4 or 100 by 5, right? So you're effectively dividing that. So you could have as well think of it as dividing 10,000 by 2, 10,000 by 4, 10,000 by 5, and so on. So only numbers which are products of whose prime factors are only 2s and 5s. Can our homework be a yeah, of course. Only numbers whose prime factorization contains only 2s and 5s will not have repetition in their reciprocals. All other numbers will have repetition because there is no common factor between 10,000 or 1 million and 3. I mean, there is a common factor, but they're relatively, they don't evenly divide. Right, so that's it. So you pick the largest number of largest power of 2, which is less than 10,000. Largest power of 2 less than 1000 is 2 power 9 512. Then another times 5 or 2 power 14 is 8192. No, 2 power 14 is not 8192. 1024, 2048, 4000. So 2 power 12 or 2 power 13 is 8192. Let's see. Yeah, 2 power 13. So 2 power 9, 8, yeah, 8192 is the highest power of 2 that is less than 10,000. So 8192 is the answer for fourth question.
I have a question.
Yeah.
Wait, it's not about the code, but how do you make how did you get that up symbol?
Oh, shift and 6 on my keyboard. Hold the shift key and hit 6. Okay, so
Okay.
that's pretty much all we had. Now somebody said sets. Anyone can say how can we use sets to find out reciprocals that are not repeating? Somebody had that very nice idea. So sets, using sets to identify. Okay, the length doesn't increase, then stop it. No, not sure. So this problem that you guys tried, actually, the first time I had tried this problem, I was trying it on a on hardware, not even on software. So this is something that the goal I was trying to achieve at that point was to identify if a signal is periodic. Do you know what is periodic function or periodic signals? Anybody has heard of this? So take something like this. If you notice, this is, yeah, periodic functions. Okay, very nice. Some of you might have heard of them. So take something like this and you keep drawing. And if you notice, it's, yeah, like sine waves. Yeah. So if you notice, this function is, this graph is repeating, right? Every time it reaches this point, between here to here is exactly a copy of between here to here. So the graph is repeating. That's called periodic signal. Obviously, it's very easy to detect if it is uniform periodic like this. But what if it's something like this? This is also a periodic signal. So we're trying to do this in hardware, like create some circuit to find this. So in software also, this is equally challenging if you are trying to find periodicity of signals. So it's actually a very hard concept if you want to generalize this. Luckily, we had something like long division, but the idea is always the same, whether it is long division of a number or long division of a signal. Idea is always the same. Split it into small pieces, check whether a given piece or a given set of pieces repeats after some point. So basically you split this into so small pieces, then check, well, what is the value, or what is the value of this function at different points. And if it repeats after some stage, you could see that roughly. It's not exactly how you do that, it's roughly how you can do that. So that's the story. Now today's class. So this is the stuff we wanted to go over in today's class. Last class we studied about functions, right? This class will still continue to study about functions itself. But where did we stop last class? We stopped at functions involving multiple inputs. A function that returns a value. Yeah, so we returned a value from our function. So that's where we stopped. So you guys probably all went back and studied some functions about some stuff or watched some videos. Can you guys think of some functions which need more than one input value? Any function. Calculator, okay. Calculator is not a function, right? It's a device. A division function, area of rectangle. Okay, area of rectangle is a simple one. That's a good one. So area of a rectangle is a simple one. Sum is a simple one, absolutely. Sum is a function that needs at least 2 arguments. So now we'll look at, already we saw if we are calling a function with more than one value. So something as area of a rectangle, we need at least 2 arguments to this, right? So you need length and width, right? So you can return length times width. This looks fine, right? Now, can you think of any function that returns more than one value? A function that returns more than one value. You're all familiar with functions that return more than one value. You have used it also. Quadratic function, very nice. Okay, so solve a quadratic equation. What are the inputs? How many of you don't know what's a quadratic equation, quadratic function? or some other function. You guys can give me other functions which return more than one value. I'm not particularly interested in one type of function. Any other function that returns more than one value. Exponential. Meghna, what do you mean by exponential returns more than one value? Yeah, no, I'm talking about return, right? Not input. Sorry. So return square root. Okay, so square root returns more than one value. That's good. So square root of some number. What should it return? I forgot about returning. Yeah, no problem. When do we learn? We'll learn soon in maybe another 5-6 classes, so another 2 months, so roughly plus or minus. Right, so how do you do that? Right, yeah. Satwik, the question is completely different from your answer. This is what happens when you don't look at the question, right? So the question is return more than one value, not accept more than one value. Yeah, we'll get there. We'll get to what are those asterisks made of. So square root is a function that returns more than one value. How do you calculate that? Plus or minus, yeah, but that's easy to say in hand, but for a computer, there is no number that is both plus or minus at the same time, right? Like number has either plus something or minus something. So I could say positive square root equal to this, and then negative square root equal to right. This is fine. So I can now calculate positive square root and negative square root. Absolutely. So now I want to return two values. How do I do that? If anyone is not following the question or at least the motivation behind this, okay, return A and B, very close. So instead of saying return A and B, it says return, that's almost there, Danishka. So you can say actually return positive square root comma negative square root. So let's see what happens if I call this function square root of 25. Comma not and, yeah, that's all. Yeah, so you just can put a comma and then it would return the values. But what is this? What does the output look like to you guys? What kind of data structure or what kind of a tuple exactly? So, but where did we create a tuple? Did we create a tuple somewhere? Nowhere, yeah. But on somehow we ended up getting a tuple. So what we did is when you return something like this, a comma b, so let's take an even more simpler example. A comma b equal to 1 comma 2. So anytime you just separate out numbers with commas like this and assign it to some other tuple, even you don't have to assign it to some other tuple also, you can assign it to some other single variable. Let's see, what does this do? I don't know if this works. So it automatically creates the tuple. You don't have to put a parenthesis around it. It automatically creates the tuple itself. So separating out numbers like this or even strings probably. So when we kept saying or when we kept on reading or when you guys read online, wherever you found the tuples are immutable, tuples should not be changed, the values of tuples should not be changed, the position of tuples should not be changed. One of the reasons for that is also this, because if I was trying to return positive square root, negative square root of a number, I want them to come back as positive square root and negative square root without getting changed anywhere in between, right? So somehow Python should have a way of returning this answer from here to here. And it internally uses tuples because tuples are immutable, right? Once you create them, they can't be changed. So Python internally favors tuples when it is returning multiple values for a given function or even in multiple value assignment to a given variable. So it's automatically creating a tuple because it preserves the elements and their order. So I would like for you guys to actually now write any function. It doesn't matter which function you want to write. Write a function that accepts two input arguments and returns two output arguments, two output values, and then print the two values separately, not together, but print the values separately. So any ideas on what functions you guys can write for this? How do you create code like Python? Do you need to use code to make a code? Yeah, absolutely. You need to. Probably the worst question, but I'm just curious. Or lists. Can you use sets instead of tuple? No, Magnus, sets is not. Sets or lists have problems, right? If Python internally was using a set for this, there is no guarantee high by will show up in the same order. It might show up as by high, right? So that's a problem. If it uses a list, it is quite possible that the list can get modified anywhere in between the time that it is returned here. And when I say in between, you don't see any code here, right? Between these two lines of code, I'm calling this and I'm assigning to this. But in this assignment itself, a lot of operations are happening. Yeah. Since a lot of operations are happening, it's calling this function, it's finding these values, saving these values somewhere, and then returning it to these values. A lot of pieces are moving in this simple one-line statement. If you are using a list or a set, guaranteeing that they don't get changed in between is very difficult. So what do I mean by print these two values separately? I want you to print, like for example, in my example, I don't want print the tuple. I don't want to print the tuple. I want to print the first element and the second element separately. On two different lines. You can think of them on two lines. Print the two values on two lines. So can you guys think of a function that accepts two arguments and returns two arguments? Any function? So that you all don't write random functions. Absolute value of a sum. Absolute value of a sum returns one value, right?
No, like what the absolute value of x can be for the certain sum.
Right, but the answer is just one value, right? So absolute value of -2 and absolute value of +2 are the same, but the answer is just 2, right? How about division? Write a division function that accepts two input arguments and returns two output arguments. Division is probably a little hard. Anything else? Oh, 25 equal to mod x. What are the numbers whose absolute value is equal to this? Oh, okay, opposite kind of thing. Okay, but you're going only one input, right? Take two numbers, add them both by 1, and then return two numbers plus 1. Okay, so very simple function. Write a function that accepts two numbers, add the first number, add 1 to the first number, and multiply the second number by 10 and return the numbers. Or actually accepts two numbers, return the sum of the numbers and the difference of the numbers. Okay, so simple function. So your function takes two numbers, calculates the sum of two numbers and the difference of those two numbers and returns those two values, and you have to print them. Again, Satvik, you're probably jumping too fast. This your function should take two numbers and return two different numbers. I know you guys, some of you guys know functions very well. So I'm not trying to test your syntactical knowledge about functions. I'm trying to see somewhat of it does do that, but it takes two numbers and it's returning those two numbers. So it's right. So two different answers. So this is the question right now. So write a function that accepts two numbers. Sure, yeah. Whichever, I don't mind whichever you do. You can do either x minus y or y minus x, whichever you want. So if anyone is having a problem with writing this function, please let us know and we can go into breakout room. Otherwise, we'll continue to the next stuff. Okay, so Satvik is actually constantly going to this function called yield. So Satvik, you can maybe, there is someone waiting in the, how do you put it on two separate lines? Yeah, you can put it, right. So let's ask Satvik some questions. Maybe he can answer instead of typing on chat. So Satvik, what does yield do? Satvik, what does yield do? Returns generator object. What is a generator object? Okay. You can speak out, Satvik. Yeah, don't have to type. You can speak out easier, probably, right? Absolutely not, actually. So it does not contain values. So first of all, generator object does not contain values. It generates objects as you are going, right? No, it kind of also does not contain. If you could return, then what's the difference between a for loop and a generator object? Why did you call it generator object and not for loop? Anybody else who wants to take a shot at this? Maybe some of you guys already know what it is not a for loop, but you're just saying it contains a bunch of values and you get the values out, right? So is it like a list? Why did you call it a generator object and not a list? Is it like a list? What's the difference between generator object? As you look through it, it returns values. So what? As you look through it, a list also returns values. When you print it, does not print. Okay, that's really just a convenience. How do you return answer on two separate lines? Okay, so first let's answer this question. So how do you return? So some of you are already, all of you are already doing this. So sum and difference of a comma b, sum of numbers equal to a plus b, difference of numbers equal to a minus b, and return sum comma difference, right? So now you want to return this, you can actually just say x comma y equal to sum and difference of 4 comma 5, print of x, print of y. So this is one answer. I'm not saying this is the only answer. You can do print of a plus b and print of a minus b, but print is not the same as return. I hope that is clear to you guys. I said return the values, not print the values, and then print them. I think I gave this example, right? How much money is in a bank account versus taking that money and spending it is two different things. When somebody is returning you the money that you have in your bank account, they are giving you that money. If they are printing, then you can't spend that money unless somebody else looks at that print and says, okay, fine, I believe that you have this much money. Right? So that's the difference. So returning means you have the cash in your hand. Printing means somebody else just says you have this much in your account. Slight difference. Yes, so Shruti actually asked a good question. So could you also append sum and difference to a list and return the list? Yes, Shruti, you can do. You can append this sum and difference to a list and return a list. Now you are returning one variable. That's also fine, absolutely fine. No big deal at all. That's one good way to return. So when you're returning multiple values, could we take a break? We only started about 1 hour ago. So we'll take a break around 11:10ish. So we have to take care of a few small issues when you're returning multiple values, right? So here in this example, I know my function is going to return two values. Hence, I'm going to assign them into a tuple that contains two values. But what if I did not know how many return, or what if my function was returning variable number of values? Do you think that's possible? Like, can we make a function return variable number of values? Sometimes one value, sometimes two values, sometimes three values. Is that possible? Okay, so what kind of function do you guys know that returns one value or two values or three values? Right, so any function that you already know. Yeah, it absolutely right. Take the last, no, Shruti, opposite. Shruti's question is, when you have two return statements, it will only take the last return statement and disregard the first one. Opposite, it will only take the first return statement and disregard the anything after that. So quadratic function sometimes returns one value and sometimes returns two values. Perfect. How many of you know how to solve a quadratic equation? Okay, so let's try that one. How do you solve a quadratic equation? How many inputs are there, first of all? Three. Okay, so I'll just say A, B, and C. Okay, you guys also like A, B, and C. Okay, so what are the roots? Okay, I'll call it root 1 and root 2. For code, quadratic formula would be easiest in code, right? Yeah, for solving. Absolutely, you're right. Quadratic formula is the easiest way to solve in code. So it's minus B. So basically minus 1 times B plus square root of B square minus 4 times A times C. And this whole thing divided by 2 times A. And the second root is minus B minus square root of. Right. So if root 1 equal to root 2, return root 1. Else return root 1 comma root 2. Is this a valid thing? Does this function look correct? What about the square root? I just said times power of 0.5, this one. Right, this is the same as square root, b square minus 4ac square root. Okay, we can test this function. So anybody who knows some quadratic solver, some answer. You can say minus b probably. I just like to put that -1 times x square plus 6x plus 9. Okay, so we'll try those two solvers. So this first one should give 2 and 3 as answer. The second one should give -3 as answer, right? So let's see if that's what happens. Oh, so this one is answer 1, answer 2, or actually fine. So we'll print answer 1 and print answer 2. So first one gives 3 and 2 as answer, second one gives -3 as answer, right? Yeah, absolutely. So how do you, now your function is kind of funny because sometimes it returns one value, sometimes it returns two values. So can I now assume it will come into a tuple like this, √1 comma √2, √3 comma √4. Why do we have to print the variables? No, shouldn't we just automatically return both? Yeah, it is returning both. Here this is returning. I'm just checking what it returned by printing. How do I know what it returned without printing? Yeah, it's not the part of the function, so it's almost like this. So now what if I printed these and printed these? So it gave me an error. So first let's do up to here and then see what happens. So this worked fine, right? So when I said √1 comma √2 equal to quadratic solver, whatever, it gave me 3 and 2. And that's what is expected because for this equation, x square minus 5x plus 6 equal to 0, the roots are 3 and 2, which we already printed here. These are the two roots. But for the second equation, x square plus 6x plus 9, the roots are just -3. Right, so it's complaining now and it says float object is not iterable. Why is it saying that float object is not iterable? Any thoughts? I know some of you guys already know some of this. So anybody who knows what's happening, it can be a tuple because it want to, and also you can't use float. Maybe no. So Satvik or Aditya, or I know at least 2 or 3 people know all this stuff. Satvik, Aditya, Jain, or no, if you guys know, why does it say float object is not iterable? Oh, absolutely, yeah, but why did we get that error? Because you put random code in the chat. Satvik, yeah, no, Satvik didn't put random code. He knows. It is not iterable, yes, absolutely. But why does it even think it has to be iterable? Okay, Aditya Jain, is he there in the class today? He's there. Because you're restructuring it, yes, absolutely. So search Stack Overflow. No need to search Stack Overflow for everything. Yeah, so what happens here is actually very involved. What looks like a very simple thing, return √1 comma √2 versus return √1, because you need a range. No, float cannot be interpreted as a tuple, so disarranged, absolutely. Oh, search Stack Overflow is the answer. Oh, okay, that's good answer. So yeah, they probably know everybody searches Stack Overflow and they're hinting you. But let's see what happens. So if I try to do this, what should happen if I try to do this? Do you guys see what's the problem here? Absolutely, error int is not iterable, but why? What is there on the left hand side? 11, 11, 11, 10-ish, yeah, we can have, yeah. Not 15 minutes, yeah, maybe 5, 10 minutes. Left hand side is a tuple. What is on the right hand side? What is int? So when you assigned a tuple to an int, which one should it assign to? Should it assign to root A or root B? Yeah, it also does not know. Right, neither. So you should not really assign. So what's happening is basically it's trying to, when you try to assign a different data type or a non-iterable data type, because integer does not have any elements, right? So you can't iterate over integers. Whereas the left side one has, on the left side, you're assigning it to a tuple. So it's an iterable collection, but it does not know. First, it has to iterate through the list on the right side and then assign one by one, point by point. So if I did it this way, root A comma root B equal to 1 comma 2 as a tuple, it's really looping through this tuple on the right hand side and pairwise assigning this. So 1 goes to first one, 2 goes to second one on the tuple on the right hand side. What if I do this root A comma root B equal to 1, 2, 3? What if I do that? First focus on this, guys. Yeah, what error would you get this time? Okay, let's see. Too many values to unpack. So what's happening is it's really called unpacking. So it's almost like you're going on a trip. You first packed your stuff. Now when you're unpacking, you're trying to stuff the items you packed into your suitcase or into your bag into a lesser number of values. So there is not enough place to put it. Hence you get an error, right? So when you are returning, these are some words, you guys can Google it up later. When you are returning something like this, A comma B, it is first packing the result. So Python is packing the result of 3 comma 2 into a tuple. And when you are assigning it to another tuple, it is then unpacking and assigning piece by piece. So it's called packing and unpacking. Oh, could you please explain again? So which error, Shruti? This one, the root A comma B equal to 1, 2, 3, that one? Okay, 169. Okay, fine. So this one. Right. So when you return this 169 thing, so let's see, instead of returning it to this, I'll call it roots. So the 169 returns just -3 as the root, right? So it is returning an integer. When I call this quadratic solver with 169, it just returns a single number, -3. No, it's because that's how we wrote the function. We wrote our function so that it returns only one root if it has one unique root and two roots if it doesn't have unique root. So the way we wrote the function made it that way. So that's part of the problem. Now, so just to reiterate what happened. So when you are returning multiple values, one way, and this is not the only way, one way is to return by packing the values into a tuple. But what is the issue with this method? What are the potential problems with packing the values into a tuple? Yeah, Meghna, it may not do anything for anybody. It just Googles like this. Sometimes too many or too little values. Absolutely, Prince said. So the potential problem with this is if the number of values returned is not fixed, then unpacking the return value can cause problems. Two types of errors. Either too many values to unpack or too few values to unpack. Let's see, does it have say too few values if I do this? Any guesses if I say root ABC equal to 1, 2, what happens? Okay, too many values. So not enough values, it says not enough values to unpack. So either there are too many values or not enough values, or not iterable, like whatever, int, float, whatever is not iterable. So you can get some errors. The first one is when there are too few values or too many values. The second one, the second two are when there are too few values. So these are the problems. So you guys can take a 5, maybe 10-minute break if you want. Those of you who want to discuss anything else, you can stay, you can take a 10-minute break, and then we'll come back and look at other ways of returning multiple values and other ways of taking multiple values. Okay, 10-minute break. But if any one of you has any questions, you can stay. We can continue, Rohan. If you have any questions, we can talk about that. If you want to talk about some stuff that we covered so far in the last 1 hour, we can talk about that. What is the error with 1, 2, 3? Shruti, you can talk. I'm not sure I understand the question. You can speak out.
You wrote 1, 2, 3, like the inputs were 1, 2, 3 for for when you called one of the functions, and it gave an error. I'm not sure why.
Like this one?
Yeah.
Right. So how many values are there in the tuple on the right hand side? How many elements are there on the tuple in the tuple on the right hand side? 3. Okay. How many are there in the tuple on the right, left hand side? Sorry, right had 3 values, left had. Yeah, clicking on Stack Overflow does something for those of you who are asking. Shruti says too. So that's why it's complaining. So it says it's basically the best analogy you can think of is like packing bags, right? When you go to your school, let's say you're taking 3 books each day. And each book, once you go to school, you have to put each book in, let's say some books is not a very easy example, but let's say you're taking 3 pairs of dresses when you're going on a trip. As soon as you reach your destination, you want to unpack your bag and put each one on one hanger. If you had only 2 hangers, can you unpack smoothly? No, that's all. That's exactly what it is doing here. Okay, so Prince says, what other functions have different number of return values based on the input? Different number of return values. So some statistical functions a lot of times have different number of values. You guys might have studied mode, for example, mode of a bunch of numbers. But if you had the quadratic function 1, 2, 3 equal to root a, it would work, right? Yeah, it would work. Yeah. If I did quadratic function of 1, 2, 3, then it should work because that one will return two roots. Yeah. Let's see. Oh, did I type a mistake? Quadratic solver. Sorry, I called it quadratic solver. So it didn't give an error. I can print root A root B. So it gave me some imaginary numbers. Oh, -1 plus square root 2j -1 minus square root 2j. Root of sounds. Okay, so we can go with, I think it's yeah, it's imaginary. Yeah, it's -1 plus root 2 plus or minus root 2j. Okay, so Prince has a good question. Are there any other functions that have more than one output? So I can think of only a few mode. So if these are the numbers in a list, oh no. So what's the mode of this function, this list of numbers? For those of you who don't know, if you don't know, I will explain. Can you put those comments in the chat? Oh, these comments? Yeah, sure. 3, 5, and 6, absolutely. So depending on the input, mode function can either have one value, two values, or n number of values, right? The number of values mode function has are, I saw you can use lumpy even though I didn't use it. Numpy? So Nipun, what were you use? Oh, for homework. Yeah, you could probably use some functions in NumPy. I don't know which functions exist. You can probably use, I'm sure there is some NumPy function for reciprocal. Maybe it is there, I don't know. But it is best for you to write your own functions. Yeah, numpy.reciprocal maybe. Oh, it's useless. Okay, good. Yeah, I don't know if it helps. Yeah, it may or may not help for this particular situation. Let's see, is there a numpy.reciprocal? A location into which result is stored, if it must have a shape that in the input broadcast to. No, it doesn't do much in our example, I think. Because I specifically made the output requirement somewhat didn't seem to do much. Yeah, it seems to do something. I don't know what it is doing, but NumPy is acronym for, I think, numerical Python. Yeah, NUMPY NumPy is numerical Python. I think there used to be at one point SciPy also, scientific Python or scientific calculation Python. So SciPy. So it's basically a collection of functions or collection of modules that can be used to do a lot of interesting scientific calculations. NumPy is a collection of functions that can be used to do a lot of numerical calculations. Yeah, break is almost over. Another 2-3 more minutes. So any other questions anyone has other than his break over? We will use some NumPy stuff in a few classes from now, and we'll use another thing called pandas. So pandas and sorry. How do you use? Not now, not now, Benjamin. We'll get there, Benjamin. It's not something you use. You have already used other modules. Like for example, if you guys remember, we did this in one of the beginning classes. We did this math.ceil and we did math.floor. Do you remember this? Anyone? Benjamin, do you remember this? No? Okay. So do you know what the function called floor does? Or do you know what is function floor and ceil? Okay, rounds down or rounds up, right? Yeah. Right, so 3.4, the ceil of 3.4 is what? Ah. Ceil of 3.4 is 4, floor of 2.3 is 2. So which is the smallest, which is the integer greater than 3.4? The smallest integer greater than 3.4, so above 3.4, the first integer that's above 3.4 versus the first integer that's below 2.3. So that's what floor and ceil do. To calculate this ceil and floor by yourself is little bit difficult. You can do it, but it's little difficult. But oops. That's why you use a library called math. When will we start group projects and stuff? I think the first place you guys can start group projects is here. Once we cover maybe, so today we are here. Either 3 classes from now or 4 classes from now, you guys can start group projects. Actually, today let's discuss a little bit about how to form groups also. Because from here, you guys can start writing certain code that is more advanced. So this math, Benjamin, to answer your question, this math that we used here is what is called as a library. Python math library. So a library like the normal library that you are used to has books. Python library has functions. Has to be quiet. It is a library. Yeah, you don't have to be quiet. It is very quiet, right? The functions inside the library are very quiet. Those are the people inside the library. So when you have these two functions, you're just saying math.ceil and math.floor. So math is a library. It is a collection of functions. No, you're using the books in the library, right? So ceil and floor are like books in the library. Math is a library, ceil and floor are like books. So they are functions. So Python libraries have functions within them. And we will explore at least two. I don't know if we'll explore more. We'll explore at least 2, maybe 3. We'll explore this thing called Numpy. We'll explore this thing called SciPy, and we'll explore this thing called Pandas. These are 3 libraries. Okay, so now that we're almost at the end of the break, hopefully everybody is back. If not, we'll still continue. So we just stopped here. We said like there is one way to return multiple values, and that way is a little bit broken. So can you guys think of any other way to return multiple values from a function? Any other way? I don't know. Pandas probably stands for something. Python data analysis library. Doesn't look like. Yeah, I can't see what it stands for here, but let's see if we go to that website. About pandas. No. Python data analysis library. So looks like something. So we'll call this Python data analysis library called pandas. So for those of you who missed the this part. We will learn in future classes. We'll learn about 3 different libraries. Libraries are like math that you guys already used. They contain some set of functions that you can use without typing. So we use Numpy, SciPy, and Pandas, 3 libraries at least. I don't know if we'll use more, but we'll use at least those 3. Maybe we'll use something for graphing. I don't know. So that's the stuff. Now coming back to the question there from before the break. One way to return is by packing these into tuples, but that has problems. So is there any other way in which you can return multiple numbers from a function back to the calling function or whoever is calling that function if you want to return multiple values back? So this function was returning as return one thing and return a comma b style. But instead of doing this caused a problem, right? When we were trying to collect the answers, it caused a problem. So how do we get rid of that problem? Can you do this? For elements in sum of difference, in sum and difference, print elements. Okay, let's try. That sum and difference function, Tanishka, was always returning 2 functions, two output parameter values, right? It was always returning 2 values. So whatever you do, it would work. But let's take our quadratic solver and see. For root in quadratic solver of 1 minus 5 comma 16, print of root, right? This is the equivalent of that for quadratic solver. So let's see if I put this here. It works. But if I try this same thing with 1, 6, and 9, it gives an error. Again, same problem. Because it returned a float, not a iterable collection. Anybody else? Shruti, one of the Shreyas, Meghna, Rohan, Satvik, Aditya, Matthew. I'm just reading off the names that I see here. I'm not calling out certain people just because. No questions. Yeah, thank you. I'm asking a question. Yeah, okay. Aditya again. Aditya Jain, how can we solve this problem? What is one easy way to solve the problem so that it can return either 1 value or 2 values or any number of values without a problem? Anybody else? Satvik? What if you returned a null value for the second root if the function had only one solution? Just to print quadratic solver, absolutely, yeah, that would work always printing. But if you want to access the values. So what are the collections that we studied so far? What are the collections that we studied so far? Yeah, absolutely. Darren, you good answer. Destructure it. So Darren has a good answer. Aditya, destructure it or always structure it basically. So our problem was because sometimes the function was returning a tuple, sometimes it was returning a float or an integer or whatever. What if always it returned the same type of data? Satvik's method is the best. Stack Overflow. Okay, search Stack Overflow does not give an answer. It gives you 100 questions. So let's see what happens if you search Stack Overflow. So what's the answer? Anyways,
For
so
me, whenever I search Stack Overflow, it just says that there's no like results ever.
wow, really?
Yeah.
That's interesting. You got a problem for which there is no answer in Stack Overflow?
Yeah, I really don't know why. I mean, when it says the value error and it tells us like where it is, and so I I'm trying to like find out. I have to search the internet myself, and then I get it. But whenever I search Stack Overflow, it doesn't do anything for me.
Wow, I don't know why that is the case, but yeah, maybe you have disabled something. I don't know. Maybe you have disabled like pop-ups or something on your browser, because of which it's blocking the pop-up that comes up. That's the only thing I can think of, but it's extremely unlikely that you would ever get a I mean, unless you are doing some very specific thing. For most of the common errors, someone or the other would have gotten this error already. Guys, you can if you want to keep searching Stack Overflow, keep searching, don't keep typing. Anyways, so coming back to this, the reason why our code was giving us errors, or at least one reason, is because we are sometimes returning a collection of data, sometimes we are not. So what if we always returned a collection of data? What are data collections, collection objects, or some types of data collections that we all studied about? Okay, list is one. Okay, any other collections? Set is another one. Any other collections? Tuples, dictionaries, absolutely. So you can always return one of these. Now, for this particular function, quadratic solver, which one is the best? Actually, we will look at some examples where all of them are good. So that's the reason why we studied all those data types ahead of time, so that when we come here, we will know which one is useful when. So for this quadratic solver, dictionary is best for quadratic solver. Why is dictionary the best? Multiple values. So does a list, and so does a list is cool. Values. So first of all, for this quadratic solver, list easy to perform calculations. List is the best. Okay. So for this quadratic solver, does it matter whether you put 3, 2 or 2, 3 as the roots? If you have a quadratic equation, knowing that 2 and 3 both are the answers to that equation, does it matter if you say 2, 3 or 3, 2? No, it doesn't. So order is not that important. So sets is sufficient. So set is actually pretty good here, right? If I added roots as a set, root 1, root 2, is this how you do a set? With a does this seem right? That root 1, root 2 is roots. Is this a set now? So let me take this whole thing here at the bottom. So I'll now say roots is a set of root 1, root 2 and return roots. Does this seem fine? Anybody sees some problem? Because I don't know, maybe I have a mistake in this code. Okay, so I think it's okay. So let's see if it's okay. So let's call this quadratic solver, which returns set with 1 minus 5, 6, and say root equal to this. So now whoever was saying for root in quadratic solver, print root, right? Let's see if this works now. So it works for the first one. Now let's see if I do 1, 6 and 9. It still works. Shruti, the reason why it probably is not working is maybe you didn't change the name of your function. So it probably still thinks that you're calling the older function. Maybe that's what I can think of. So now we solved the problem where we wanted to return two values versus one value, we still always get, we can always group the values. Right, so it looks like we solved our first problem, at least with packing, unpacking, right? Does this look like that we solved the value problem? Sort of, yes. It looks like sort of it solved the problem. Almost there. Okay. So now think of a function where order of the answers is important. Think of a function where the order of your output answers are important. Can anyone think of a function that returns multiple outputs? What is that? Less LCM, least to greatest. Okay. Okay, so sorting basically. So sorting is a function where order is important. Okay. So if our function was defined, but sorting is something that's prices, date of a day. But I'm thinking of a function, not necessarily of a general use case. So some function which takes some inputs, returns some outputs, and for which the order is important. Functions can only return one output unless it's a generator. You can disguise multiple outputs as a list and then destructure it after calling it. Yes, absolutely. But even a generator is returning one output per iteration, right? So that's all semantics basically. So Aditya is absolutely right. Like, so when I returned this roots, did I return one output or multiple outputs? Right. But if I return one output, but if that one output contains 100 elements within it, then that's the same, right? So if it returns a collection of answers, we could as well think of it as returning multiple answers. In this case, we had two roots. It returned two roots. But you're right, absolutely right. Like it is always returning one address. Basically, these are all pointers to some location. So it is always returning one output. Even when we typed return a comma b, the output was just one thing. It was a tuple. When we said return root 1 comma root 2, the output was just a tuple. It automatically made a tuple. But since some of you guys already came up with this thing called generators, we'll probably pause for a second here and go to this other idea of generators. So a simple function, numbers from 1 to n. So I want to return one number at a time from 1 to some number n, right? So number n is my input. So what do I do for this? Obviously, the easiest way is use range, right? So we'll try to define our own range function. Okay, it only takes like start and end for now. So one set with multiple numbers, for loop. Okay, use a for loop. So what if I use a for loop? So for what? Without using range function, I want to write our own range function. No, the range function does not return a set or a list, right? It returns one number each time you call it, and the number is one greater than the previous number that you already got back, or whatever is the increment greater than the number you called back. Right. So range function is not returning a list. Oh, instead of returning as a set, yeah, absolutely, Kavya Sriraj. Instead of returning as a set, you can return as a list also, no loss. So I could as well have done this. But when I do it as a list, it repeats, right? The repeated roots are coming up 2 times. So this one, it shows -3 2 times. So that's the only reason I did a set. When I was returning it, I was returning it as a set. So without using a range function, if start equal to, no, don't worry about all this. Assume that my start is less than end, and start and end are both positive integers. Append it to a list, at the end print list. But I don't want to print list, right? I want to return one value. Anybody, Satvik, Aditya, you guys already wrote your own functions for this when we were talking earlier. So one way is to use this thing. So those of you who don't know this part yet, for I in range, but without using range. I don't want to use range. I want to write my own range function. And it soon be visible why we are trying to write our own range function. R.append return R. Okay, Satvik, if I do that, it's returning an entire list, right? It's returning an entire list, but I don't want to return a list. I want it to return one number as we go forward. So just because this is probably not something that you have seen earlier. So if you had your function, so let's say I create a function dummy or increment function, and I pass a number, and I say yield I equal to number plus 1, and now yield of I. Instead of return of I say yield of I. So let's call this function once. Looks very simple, right? Like it's just doing plus 1 and then returning it. So if I call this function once by passing a 3, what should be the output? Yeah, so it looks like return, right? It looks like return. So what should be the output, Meghna? 4. Okay, let's see. So it says print, you cannot print. So what's yield? Yield is basically similar to return. You have to have return. No, you don't have to have return. So let's say what happens if I do this. It's returning a generator object. So if I call it for I in increment of this print, or for y, so it now printed a 4, right? I don't have to return. Yield is similar to a return, but instead of returning a particular value, can't you say print of I? Here, yes, I can say print of I, but again, the same thing. Print of I is not the same as return of I, is not the same as yield of I. So we have 3 things now. You can print an answer, but that just means you are displaying the answer and not able to access the value for future manipulation. You can return an answer and use that and store the returned value in a variable and manipulate it later. Or you can yield an answer and then loop through the function yield and access the values. So yield is like, it's a way of lazily returning the answers in one way. There are lots of use cases. One way is to lazily return answer. When I called it increment function of 3, it didn't actually return the function. Only when I said for y in this range, yeah, Simran, you can do that, but we'll go over a little bit a slightly different way. We don't want to print, right? Because when you print, you are not getting anything out. You are just showing it to somebody. Yeah, we'll slowly get there, Nida. Yield is not returning one value. It can return many values, and we'll see how in a second. So if I do this, I'm just getting one value, right? So it doesn't look any different from return. But what if I kept, instead of returning I versus this, if I said number equal to yield number, what would this print 4 still? So now let's go to the one that I wanted to try, which is define our own range function, start comma end. So I say I equal to start, while I less than or equal to end, or while I less than end, yield I, and I equal to I plus 1. Now let's see if this one takes it. So now I'll call my our own range function with 2 comma 10. So now it printed 2, 3, 4, 5, 6, 7, 8, 9. But I didn't return a single list. So if you want to verify that whether I returned a list or not, you can check here. If I just call this, it doesn't return a list. It says it's returning some generator object, right? Each time I call this function, it's giving me a different number. So how do I prove that it's giving me a different number? Because I'm printing each time I call this function, it's printing. And when I call the function individually directly, it doesn't do anything. Or the other way is I just print this I here, right? I'll print I to just show what it prints each time. So now I call this. So just to make sure, printing one value from here, function. So it's printing the value from the function and then I'm seeing it, right? This is different from return. So if I did return, for example, and then I call this, then I just get 2, right? Oh, okay, actually, so let's see if I make it, if I do call this way. So it printed 2 and it stopped, right? Even though I have a while. Can you please repeat? Yeah, so now it will be very clear and how generator object, you don't have to avoid it actually. So it's actually a useful thing. When I return from a function, the function stopped at this point. It no longer continues. When I call this function, our own range function of 2 comma 10, and I print it, it stopped. You need to print the function outside the function in order for it to work. Not really. So when I said yield of I, instead of stopping the function, when I call this function, it returns one value, then continues this function. If I call it one more time, it will return the next value. If I call it one more time, it will return the next value. So just to illustrate that point, I'll say for I in range 1 comma 5, let's see. So not in for y in our own function, our own range function of 2 comma 10. If y greater than 6, break, else print of y. Oh, I changed this. So I have to compile one more time. I'll remove the print. So see, it stopped at 2, 3, 4, 5, 6. So it's each time it calls the function returns a different value. You can even make it return the same value. So along with yield, you need to print the function outside the function. Now, yield is useful when each time you call your function, you want to get a different operation. You want to move forward a little bit, one step at a time. If you used your method like what Simran has done or what all of you guys initially said, if you used a for loop to generate this list, then you already have generated the list. What if I want to generate a billion values? Would you generate all of them first and then start looping through them? Instead of that, this generator function method yields one answer at a time. So you are nowhere storing 1 billion values. Each time you call the function, you get one value. Next time you call it, you get another value. Does that make sense? So yield basically stores the answer of stores or returns one value, and then next time when you call it again, it continues from wherever it stopped. Whereas return just stops the function's execution, and after that you call it again, it starts from the beginning. Yield stops the function's execution at this point, and when you call it next time, it goes here and then continues. You can think of it like that. So yield is like braking your car, return is like crashing your car. So when you return, you're done. When you yield, you are stopping. You can still continue from wherever you yielded. Hopefully this analogy makes it clear. Is anyone else not clear about yield versus return? I would rather print my car on piece of paper. Then you wouldn't go anywhere, right? So you have to go in your car. Whether you brake or whether you crash, that's a different option. You could take a photo of your car. So that's at least one way. So today we basically so far looked at a few things. We'll also look at one more thing and then pause and then discuss homework and something that Shruti brought up about team projects. So far we, in last class plus this class together, we studied how you can pass. When will the scores come? I don't know. We have to see. We'll reply. Maybe we'll try to finish this course. Last class, I think already home scores are up. This class are probably not there. You will have to check. I don't know if some students' scores are missing. We'll answer that at the end. Homework related questions we can talk at the end. Okay, so back to this thing. So far what we studied is basically in today's class is you can have a function return multiple values like square root function. It can return a positive and negative square root. You can, when you return by separating them with a comma, it actually Python internally converts this into a tuple and returns it back. This method is useful when you have the same number of return arguments. You can make them a tuple or a list or whatever and return it. But if you have variable number of return values, sometimes one value, sometimes two values, sometimes many values, then this tuple method runs into problems because you can't anymore unpack it into a tuple. So when you're trying to unpack, you have a problem. One way to solve that problem was basically to always return either a set or a list or a dictionary. So you're always returning one variable back. And then we saw what is something called as a yield function, yield as a way of returning a value from a function. There are three different things that you guys seem to be all using interchangeably. When you call a function, you can print something, or you can return the answer, or you can yield the answer. Printing the answer just means showing what's the value, and you can't use the answer in some other calculation somewhere else. So if I print my roots of a quadratic solver, I can't find out the sum of the roots after I find the roots, right? I can't find out outside of this function. If I wanted to write another function which says sum of the roots, I can't do that because you printed the roots, you didn't sum it. And why would I not want to go back here and try to add the sum? Because this function's purpose is to return roots, not to do the sum. If I go change it, then I'm changing the meaning of the function. So printing is not the same as return. Return is once you return a value from a function, you abruptly stopped it. And finally, yield is not the same as returning a value. When you yield a value from a function, the function runs up to this point. We'll talk about your questions. What is Python, advantage of Python? Yield comes up to this point, and then when you call the function again, it resumes processing from the line after that. So let me make a simple function, yield example. Maybe this function is very clear. So yield 1, yield 2, yield 3. So this is a very simple function to show the meaning of a yield function. For output in yield example. So this function now prints 1, 2, and 3. Instead of this, I can even, but if I call this function only 2 times, now I only call this function once, it only prints 1. If you just print yield of example, it doesn't do anything at all. It says that it's a generator object. The same as range, for example. What happens when I print range of 1, 10? It just says range of 1, 10. It actually didn't print anything. So range function was actually yielding your answer as you go. It was not returning a list, right? So if I say list equal to list out equal to range of 1, 10 and print list out, it still says range of 1, 10. It did not actually return any list, right? So that's yield versus range. Now we'll just learn one more thing for today's class, which is, so far we looked at functions which take 0 arguments or 1 argument or 2 arguments or 3 arguments, right? So we looked at functions that take 0, 1, 2, 3 arguments. What if we want our function to take variable number of arguments? Yeah, we'll discuss the homework in 2-3 minutes. What if we want our function to to take variable number of arguments? And we don't know whether it may be 1 sometimes. Yes, absolutely. So Satvik, maybe you can explain what does that asterisk args do? Anybody who wants to explain, you can explain. So can you think of a function which has variable number of arguments? Max, okay. So max, Satvik says LCM, okay, LCM or max, a polynomial with degree. Okay, very good. So you guys know some functions. So let's say a function called max, I want to find with 1, 2, 3, 4, 5, 6, and so on, right? In this case, I have some number of arguments. Some other case, I may have just 2 arguments. In another case, I may have 3 arguments. But how do you write a function that can accept any number of arguments like this? And that's where that args is helpful. So define function with many arguments. Try and accept, we will try to learn next class. This class we probably don't have much time. So what do? You say star args, right? And then you do max of args, or Oh, yeah, yeah. Sorry, I didn't even see what you guys. Try and accept, yes. Does max work with one argument? I don't know. Let's see. Does max work with one argument? Looks like max doesn't work with one argument. It needs at least two arguments. So max needs at least two arguments. So we want a function with many arguments. How would you write a function with many arguments? One argument list, return max of args. So this is how you would write multiple arguments. When you put asterisk and args, Python automatically knows you are going to give it a bunch of arguments. So we'll call this function with many arguments with two arguments and see. So 1, 2, 3. So we'll call with three arguments. So it returned 3. If we called it with two arguments, it returned 2. So as you can see, when you want to make your function accept variable number of arguments, you would say asterisk or args. What is k args? Don't know. What about asterisk kw args? I don't think it's about asterisk asterisk. So two asterisks basically. It's not one asterisk. When you say asterisk args, you are giving it multiple arguments. When you do asterisk asterisk arg, kw args, so when you do asterisk asterisk k args, you are passing a dictionary of arguments. So those arguments are something like this, basically. So last class we studied about optional parameters, right? Actually, you know what? We'll pick up from here in next class. Let's just finish this multiple arguments one, and then we will go to kw args. So you can call it anything other than asterisk args also, I think, like params. So you don't have to call it asterisk whatever. Just putting this asterisk in front of your parameter makes it accept multiple values. Now, what if after these multiple values, I want to accept, let's say, a fixed value. So now this is not really the case because it takes fixed a variable number of arguments. But if I wanted to take a fixed value, a fixed parameter and then variable, now it takes, let's say I put 4, 2, 3, 1. Now it would give you 3 because now first 4 went into the fixed parameter and then 2, 3 and 1 went into the next parameters. So we'll look into this one in next class in little more detail about how functions with multiple arguments can behave. It's similar to how returning multiple arguments works, but we'll look at something where functions with multiple arguments and named value arguments. So in next class, if you guys want to study something before next class, you can try to learn something about this. Functions with multiple input arguments, functions with multiple named arguments, functions with default valued arguments. This is what we'll study in next class. I think we already discussed this a little bit in last class, but we'll study this in next class. So for today's homework, we simply studied just two things in today's class. So I'll try to give one hard homework, one hard problem and one easy problem. And report not necessary because we studied just very little in today's class, which is how to return multiple values from a given function, right? So a simple question. Anybody has any suggestions for me? What is it in simple question? Yeah, no report, because the report is just 4 or 5 topics or 4 or 5 lines really. So no report today. So a simple question. Oh, yeah, okay, fine. Optional report. So a simple question about function which returns multiple values. Okay, yeah, easy question. Make a function that adds and subtracts two numbers. Wow. Okay. Okay, let's see if we can come up with some question suggestions. Make a function that adds two numbers and subtracts the smaller number from larger number. Okay. Returns sum and difference. Okay. Yes. Oh, somebody said make a game. Actually, I wanted to give that. Okay, let's see. Yeah, we can write a few functions that are worth one point. Yeah, make a game. So I had a suggestion for how many of you know Wordscapes?
I do.
No, okay, Wordscapes. It's like this. So you have to mobile gaming, a typing test. Typing test. A dice game, that might be difficult. Okay, Wordscapes actually fits into some things that we learned so far. It uses some ideas that we have learned so far. So let's say I'll give you guys a dictionary. And so a dictionary, this is a dictionary file or files. I don't know if it will be a single file or multiple files. So you'll get a dictionary or a set of dictionaries. The input to your function, so Wordscape generator. So basically instead of solver, you have to do Wordscape generator. So you have to generate a Wordscape like puzzle. So the Wordscape generator will make it simple. You have to generate, let's say, a 6x6 Wordscape puzzle. This is a hard question. So if you guys don't know, you can do steps of it, but it would still be something very interesting for our future classes and as we learn. So this Wordscape is a gigantic one, but let's say we want to just take a simple small one. Let's see, where is a small one? Okay, something like this. You pick a 7-character word and you fill a grid with 1, 2, 3, 4, 5, 6, 7. So with 49 cells. So your goal is to generate a 5x5 Wordscape generator by taking a given word, a 5-letter word. What I mean by that is, give me a 5-letter word.
Weird.
Okay, weird. Okay, very hard 5-letter word. Okay, now from weird, tell me some 4-letter words that you can make with weird. Ride. Okay, so that could go R-I-D-E, ride, right?
Wire.
Any 3-letter words? Any more 4-letter words? Sorry, somebody said something. Dire. Okay, so let's say I want to put D-I-R-E, dire, right? Okay. Wide, W-I-D-E, wide. Okay, so I could probably put that as here, W-I-D-E, wide. right? So what else? Drew, D-R-E-W, Drew, okay. D-R-E-W, Drew. Now how about three-letter words? Die, D-I-E, die, okay, so D-I-E, die. Wired, that's, can I get wired anywhere? Here it's probably a little too difficult to get wired anymore. No, inside this matrix. So if I want to write wired, I have to write it. The W is locked right now. I'm locked with the W. So red and wed. Okay, red. Do I have space to get red? I have space to get rid, but that will make a word again. No, I don't have space to get red also. Rid. Yeah, that's what. If I do rid here, then this will become didy. That's not a word, right? So I don't want to do rid. In fact, I don't even want to do this dire because it's exceeding the size of my array. So I'll get rid of these. So this is a 5 by 5 matrix now, right? Or a 5 by 5 array. For those of you who don't know matrices, this is just a 5-line array, right? Or a 5 by 5 list, 5 rows and 5 columns. Obviously, this is not the only solution. There are a lot of other 5 by 5 arrays that you can form from this. But this is one of them that you can form, right? Rid is already, no, it's not about, you can come up with words that are repetitive also. There is no problem with, how do you check if it is a word? I will give you a dictionary basically. I'll give you a dictionary. So your goal would be to generate a grid like this. Right? It doesn't matter if this is the exact same grid. You can come up with different grids. There is no one right answer to this question. So you can either do this. Next class, maybe we can learn how to solve this. So if one team produces this, so let's say one team produces this, the other team has to solve this. Maybe your output should say excess here, right? Or some red color excess. So one team gives one group gives a dictionary, the other group solves or gives this, the other group solves this. Yeah, that's what we'll discuss about formation of the teams now. So does this sound like you guys can do it? Do you guys want a different one? Tic-tac-toe or any other? Class is over. That's why we are discussing about homework. This is a little too complex. Yeah, this is a little too complex. Yes, definitely. There is no doubt about it. So to make it a little bit easier, I'll tell you maybe I'll give you some constraints in this. I don't know what constraints make it a little easier. Yeah, whoever wants to leave now, you can leave, but I will not explain what the homework is. And if you don't do the homework, then you'll not get points. So if you want to leave, yes, you can leave now. Yes, this is actually pretty hard, but I'll give you some hints or some answers such that.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramatrical.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the end. So bye!